Hey everyone, welcome back to Remote Sensing Pro. In the last tutorial, we built a binary land cover map with NDVI. Today we are going to take it further with multi-class classification in Python, separating water, bare soil, and vegetation. We will threshold NDVI into 3 classes. Visualize the results and measure their areas. And remember, this same approach can be extended to more classes if you need 4, 5 or more categories. If this helps, don't forget to like the video and subscribe for more tutorials. Okay, this is the NDVI we used for the binary classification. We're using the same NDVI for this multi-class classification. We've got the first set where we use the glob library to import the 2 bands that we need, the band 4 and band 5. And then we have rasterio to read both arrays. We have numpy that we use to do the calculation for NDVI. The equation is near infrared minus red divided by near infrared plus red. And we also ensure to set all the invalid pixels, or rather the pixels with 0 value, to NaN. And finally, we visualize our result. Yes, we also printed the minimum value and the maximum value for the NDVI. Alright, so I'm going to run this code so we get the NDVI that we need for this classification. Great. Okay, here we're going to set simple thresholds and create the 3-class map. Let's do that. First, we need the water threshold, and we get the vegetation threshold. And in between those, we can get the bare soil class. Okay, let's start with water. We do water threshold is equal to 0.0. Yeah. And we have vegetation threshold, veg is equal to 0.2. Remember, we used this threshold for vegetation in the last tutorial when we did the binary class classification, right? So we want to make sure it's constant here. Alright, so we've gotten the first and second thresholds. Now let's build land cover map using these thresholds. Land cover is equal to numpy.where NDVI. The first one is when NDVI is greater or equal to the water threshold. Okay, we have the first class for the land cover. Okay, we can do the same for the second and the third, but let's do the third one first. For the third class, we're going to do NDVI greater than vegetation threshold. This is same as what we used before. When NDVI is greater than the vegetation threshold, that is going to be our vegetation. So 0 index is the first one, the second one is going to be here, and the third one is 2. Okay, so we're going to have 0, 1, 2. Let's get the bare soil. Land cover is equal to np.where. Alright, we're going to enclose the rows within this bracket, and our first row is going to be NDVI greater than this one, this water, and the second one is when NDVI is less than or equal to the vegetation threshold. Good, and now we have our class 1, which is the bare soil. So get a land cover. Awesome. Let's have a look at this one more time. We have the first class, which is water class, and we are going to give it the first index, 0. We have the second land cover class, which is the bare soil, and we're going to give it the second index, 1. And this is the last land cover class, which is vegetation, and we're going to give it the index 2. So we have 1, 2, 3 classes. One last thing we need to do before we go ahead to run this code is to ensure that we set all the node data pixels to -1. We don't want to include all those invalid pixels in our classification, right? We want to ensure that they are maxed out from these classes. To do that, we're going to keep track of the NANs. We do land cover is equal to numpy.full. We do NDVI dot the shape of the NDVI for -1. We do dtype equal to numpy.int 8. Once we are done with that, we'll now go ahead to create this. For the invalid pixels, we do numpy.where, numpy.isNone. For the NDVI, we do -1, set them within the land cover. Alright, let's run this code. Awesome. I think we're good. The next thing we need to do is to visualize our result. Let's have a look at how the map we just classified is going to look like. plt.figure, we'll do fig size is equal to, let's do 6 by 6. Then plt.imshow. Alright, I think we need to show the NDVI side by side with the land cover class. That will make sense more, like just our tradition, right? So let's get the subplot, plt.subplot 1, 2, 1. That's gonna be our first plot. And then we do plt.imshow NDVI cmap is equal to, keep it red, yellow, and green. Let's give it a title, plt.title. Just give it NDVI. And we also want to keep the plot plane. Sometimes it's important. Just turn off the axis. plt.axis, we turn it off. Alright, we're going to do the same for the second plot. So we'll just change this to 2. And I'm going to come to this one first. Let's give this a title. The second is going to be Multiclass Landcover. To be able to show the 3 classes we just classified, we're now going to use this color scale that is continuous as the NDVI color scale. We need a custom color to give each of the classes, and to do that we may need to import a library before we can plot this map. From matplotlib colors, we're going to import the listed color map. Alright, and so we're going to customize the color we need for our map. Since we're using it for C map, I'll just give it C map for my 3 classes, and that will be listed color map, listed color map. Alright, let me grab the colors and let's get the colors. I'll start from water and I will just do blue color for water. The second being bare soil, which is at the middle, we'll do yellow or orange. And then the third one we'll do green because it's vegetation. I'll do blue for water and then yellow for bare soil, and then finally green for vegetation, and then you close it. Now we've gotten the customized colors for our map, we can go ahead and add it here for the aim show. So remove the NDVI and add the land cover that we maxed out the invalid pixels with -1. Alright, so we do np.where land cover is equal to -1. This is numpy.nan. Then with that we can plot the land cover and close this bracket. Let me go through this real quick. We've got the plt.imshow, np.where, we have the land cover that is equal to -1. Nana, no way. This is nan and not nana. We have numpy.nan and the land cover. Alright, it's looking good. And then we have our customized color for this map. Now let's go ahead and do plt.show. And before we show, we tighten the layout, plt.tie layout, to tighten the layout. Okay, let me have a look. Okay, we have an error here. We have to change this as well. And then we have one bracket missing here. Let's go ahead and run this code. Awesome. Okay, so here we've gotten the multi-class land cover map besides the NDVI. So we've got the 3 colors that we set, the blue for the ocean, the yellow for the bare soil areas, and then we still kept green for our vegetation. This is great, isn't it? Okay, let's move on to the image animation. This is always optional, okay? You don't have to do this. If you don't want to, you can just move on to the next part of this video, but I will just show you what we have here and then we'll go ahead to run this code so we can have the transition from the background to the multi-class classification map that we just did. For this image animation, I explained this before, but I will just go through this very fast. We've got the library we are going to use for this mapping. These are the animation because we want to do animation, right? And then we have the RC, which is the runtime configuration that renders the animations inline in Jupyter. And we have these classes that we've already created. We have 0, 1, and 2. And then we're going to set up the canvas. We're using 1 by 1 because we're plotting one map and not 2, like side by side that we did here. We're just plotting one on top of each other. And so that's why I'm keeping it 1, 1, 1 here. And want to have the NDVI to be the background image. So once we get the result, we're going to see the NDVI first, and then the rest will just overlay on top of the NDVI and just fade one after the other. For the overlays, we're going to start invisible. So we have the first one, we have the second one, we have the third one, ranging from water to vegetation. Here we've got the alphas, where we want to make it run from 0 to 1 within 25 frames. And finally, we've got the anime, the main function, where we've got the figure we have the update, where we define the function to return these three colors, three class that we have here. We also have the interval to be 100, which is going to be 100 milliseconds per frame. So finally, this set of code is just to control what we have here to ensure that we're not going to have to plot extra map outside the animation. So this controls this entire code here. Alright, let's give it a go. Here is our animation map. Let's have a look. I would like to change it to loop. Okay, so it's going from water to bare soil areas and to vegetation. Okay, so this is just a way to kind of present your result if you love animation. If not, you can still use the normal map that we have here, which is the multi-class land cover map. Very simple. Sometimes I love to play around with animation because I think it's really very interactive and it's very interesting to look at. Alright, let's have a pause for that. Okay, now let's go ahead to measure the class areas in hectares. I brought down the code we used in the last tutorial, and so we're going to modify this code to use it for today's classification. Alright, so we've got the rasterio to open band 4 just to get the transform that we need here. And we have the shape, we have the pixel width, the pixel height, both in meters. And so we need the area in meters square. That's why we need these width and height. With those, we can get our areas by getting the product, pixel width multiplied by pixel height. Okay, and in the last binary classification we did for vegetation and non-vegetation. So today we're going to do the three classes instead, right? And so let's just change this to water pixel, this to vegetation pixel, and we have the middle one, which is the bare soil pixels. And for this, we're going to have numpy.summit within the land cover when it's equal to 1. So this is actually our 1 here. So 1, let's make this 0. This is 1 and this is 2. Right? Now for the area calculation, we just change this once more to water. For the water area in hectares, we're going to have the water pixels. And we're going to do the pixel area in meters square, which is the same, no issues. And for the vegetation, we keep it the vegetation area to be vegetation pixels as this one. And keep this constant. Now we're going to bring it this one here. We'll just copy, paste, and change it to this one. We just do bare soil. We'll do bare soil here too. And we keep the rest constant. Alright? So with these calculation here, we can get the class areas in hectares, but just in case your report or your research is focused on grabbing these values in square kilometers instead, we can also, just for that purpose, add the kilometer square results to help us get to values instead of just the hectares. We'll do that by water in square kilometers. Let me just do km2. That's equal to, we're going to get this area here. The area in hectares, we're going to divide it by 100. So when you divide hectares by 100, you're going to have your square kilometers. This way we're going to have 2 results for each class. Alright, let's copy this and add it for the rest. We're going to change this. Okay, we got this one for water, then we just change this for bare soil. Bare soil. And we're going to have this bare soil in hectares. Then we have vegetation hectares. And vegetation here. We'll do vegetation in kilometers. Alright, so here we're going to have hectares and square kilometers values for the areas we want to measure. That makes it even more interesting. Alright, so this part is to print out the result of what we have done here. We have the results for hectares from the last tutorial. You can see we have vegetation and non-vegetation. We're going to change it to print our new results for today. And so the first we're going to print for water. And we do that for this water area in hectares. And the second we're going to do bare soil. Bare soil. That's interesting. And we'll change these to bare soil as well. Bare soil. Soil. And finally we have for vegetation. Vegetation. We'll get this vegetation. Okay, we have print water, print bare soil, and print vegetation area. Okay, we'll make sure that is the same. Water area, bare soil area, vegetation area. Okay. Alright, so we're going to add extra code here just to make sure we'll be able to print this result, because this is just for hectares, right? So we're adding extra one here to get the square kilometer values that we just added there. Alright, let's grab the first one for the water. And we'll do the same for the rest. You know, I love to copy and paste because it helps to minimize error for me. And I would do bare soil. And I would do vegetation. Now let's add the final one. We're going to add, since we've gotten the hectares, we're going to add the square kilometer here. We just do SQKM. SQKM. And finally, we have the SQKM. Let me go through this code one more time to remove every error that we may have. Okay, we have to see here. Okay, and then we have 1 equal to. Alright, let's see what we've got. So we have the water pixels area value to be 238 plus hectares, and this is the conversion to square kilometers. We have the bare soil, which is lower than water area, and also the corresponding square kilometer value, and vegetation. Okay, let's visualize it to help us to make this decision properly. One more time, this is for the last tutorial for vegetation and non-vegetation. So we're going to modify this code to get our 3 classes. We're going to start from water. The second is bare soil. Let's label it in full. Bare soil. And the final one is vegetation. Okay. Water, bare soil, and vegetation. What's missing? Okay, because I'm wondering why is everything red? Okay, it's okay now. And we have the auto percent in 1 decimal. And then we have the percentage label. We also have the colors before to be green and gray. Today we're going to modify it to... What did we use for the classification? Okay, we used blue for water, and we did yellow for the bare soil, and we have the green as usual for the vegetation. Okay. The land is green, can't you see? Okay, that's too much. Alright, we're going to now go ahead to plot this. Here we go. We didn't specify our classes. We're going to specify the classes right now by having the water pixels. We have the vegetation pixels for sure, but that's number 3. So we have the bare soil pixels. Water pixels, bare soil pixels, vegetation pixels. Let me check this one more time. No spelling issues. Be soil pixels and vegetation pixels. Okay, that should work. Let's go ahead and run this code. Awesome. Great, this looks good for sure. So this is 40.5% vegetation, same as what we got from binary classification. And then we have the non-vegetation part, which we've classified as water and bare soil. For water, we've got 44.1% area, and we've got bare soil to be 15.4%. This is amazing, if you ask me. Now you've built a multi-class NDVI land cover map. You can use the same workflow for your 4, 5 or more categories. And we've also seen the animation and the area statistics in hectares and square kilometers. Remember, NDVI is great for vegetation, but sometimes in turbid coastal water, it can misclassify sediment-rich water as bare soil or sand. So in the next tutorial, I will introduce NDWI, which is designed for water and handles coasts much better. If this helped, please like the video and subscribe for more remote sensing and GIS tutorials. See you in the next one.